Hey, good morning, everybody. Um, we're going to talk in this video about quadratic forms. In fact, in the next couple videos, we'll talk about quadratic forms. So this video is pretty much going to be a review of some stuff we did in 7.1 in our discussed notes. We talked about a vertex, axis of symmetry, and all those things. Well, I'd like to go back over it in this video, and we'll kind of tie it together with what we learned about x-intercepts in the next video. So let's get a sip of coffee here with my math mug, and let's get to work. All right, so the very first thing you want to do is tell you really, if you want to take notes on this, you can, but you've already got this in your 7.1 discuss notes. All right, so we're going to pretty much go over everything we talked about in 7.1 one more time here. All right, so we've been given a quadratic function here. Here's the standard form. Remember, vertex is denoted with the letters H and K. And our example is this guy right here, 3x squared plus 6x minus 4. The value of A is 3, the value of B is 6, the value of C is negative 4. Okay, and if you'll recall, the number right here in front, A, the value of A, or the sign of A really tells me whether this parabola opens up or down. And since our A is 3, we're going to say this parabola opens up. And it's definitely positive, so we expect this thing to be opening up. All right, and that's one of the easiest things to see, and that can speed you up just knowing that. All right, look, we get down here and we start talking about an axis of symmetry. All right, the axis of symmetry. And I've put one in Desmos here so we can kind of discuss this for just a second. Here's a quadratic function, the parent function, the simplest one of all. And so your axis of symmetry is a vertical line. In this case, it's the y-axis. And every point on this parabola is equal distance from that line. If you take a look, take a look at this one, we'd say, well, this guy, this is 2 units, and you can see it's symmetric, and anywhere you go, that's true. And that's why it's called a line of symmetry. Right? In other words, you could fold this parabola over along this line, and you'd have an exact copy. Okay, so I'm going to go back to our notes here, and our job is to compute this. Now, that line changes as your values of A and B change, okay? So when we compute this thing, negative b over 2a, well, that's moving us around. So we have different values here, so let's plug those in. All right, so our negative b, so we got 2a, and what's negative b going to be? It's going to be negative, that's not where I want to be. Negative 6, right? Always change that sign. That's what that negative b means. And this is equal to negative 6 divided by 6 is negative 1. So now we've computed it. So this h has moved us left 1 unit. Okay. All right. So to compute the vertex, and sometimes this is the trickiest part for a lot of people. Okay. So it says at this point you found h. All right. So the x coordinate of the vertex is on that line. Because remember, this vertical line goes through the vertex. And that x coordinate right there on the left you're looking at, that's your h. Okay, so we've found that number now. And we're going to come down here and compute the k. So what we have to do is evaluate our function at negative 1. So we're just going to plug that right in here. F of negative 1 equals 3 times negative 1. Let's do some squaring on that thing there. Plus 6 times negative 1 minus 4. And what's that going to give us here? A little basic math going on. All right, so we square that negative 1, that becomes a positive. So we get 3 minus 6 minus 4. Well, that's looking a lot like a negative 7. Okay, so now we've found the vertex is an ordered pair, -1, -7. Remember, the vertex is a location. It's an ordered pair. Okay. Okay, so that's usually the toughest part of this thing. And why are we doing it all by hand? Because sometimes we have to. Sometimes we have to do these by hand. Now, of course, throwing in a Desmos or a calculator is preferable. It's really fast, but we can't always do that. All right, let's take a look here at something that's the easiest thing of all to find, and it's the y-intercept. The y-intercept is always c. Okay, so for our example here, it's -4, and you can always see it. You don't have to work hard for a y-intercept. And some people get confused when they don't see a value for c. Well, if that's the case, then plug your 0 in for x, and you'll find that the origin is the y-intercept. Okay, so in our case here, our y-intercept is 0, -4. And we're not working hard for that. That was an easy one. And you've already found the value of k. It turned out that it was -7. So the minimum value, or it's a maximum. In our case, it's opening up. So it's a min value of -7. Okay? And that's all that information we needed. So let's plug this thing into Desmos and take a look at it. And I'm going to leave this one in there for just a second, and we'll turn it off, and we'll come back to it. You know what? Oh, just in case y'all don't realize this, you can copy and paste to Desmos. Well, some people can. Here, I don't know what it's doing, so I must have copied something wrong. But anyway, I'll just type it in. And we have +6. X -4. Okay, so there's our quadratic function that we just spent some time on. Let's see, there's our vertex, just like we expected. There's that y-intercept, just like we expected. And you can see how those values of a and b have moved this thing around. Anyway, this is just a quick review for you. I hope you found this video helpful. And in the next video, we'll start talking about these x-intercepts a little bit more and put some of this stuff back together. Anyway, you guys be safe, stay healthy, and we'll see you soon.